Hey, this is Mark Silver. I've got an actual data collector. This is a Surveyor 2 that's running, and I'm sourcing data for it through Altopo Maps. So I can put my cursor next to any waypoint in Altopo, and it will spoof a location back to the GPS receiver. So we're going to do a series of localizations to demonstrate how to localize in SurvCE. Let's make a new job. We'll call it my initials. And this job's going to be in Utah Central. I like to check and make sure that we're entering angles and bearings. The first thing we always want to do in every job is make sure we've got an appropriate geoid loaded. You can do that under Equipment, Localization, on the GPS tab, geoid file, and we'll pick one that covers this area. Now, the things that are going to control our localization is 1-point azimuth. When we do a 1-point localization, I'm going to pick state plane grid. That way our resulting grid will align perfectly with Utah Central. And then let's store the northeast corner. And now let's inverse between those points. I'm going to make a note down here that the horizontal distance is 5283.692 and that the bearing is north 1 degree 1841. Let's make a new job and we'll assign a scale factor based on the southeast corner of this section. Go to File, Job, make a new job from scratch, go into Equipment, Localization, and first let's check and make sure that we've got a geoid loaded. We do. Let's go to Use Grid to Ground, and we'll just read the GPS receiver. First we'll make sure we're standing down here at the southeast corner, read the GPS receiver, and you'll see that it's going to assign the scale point to be the southeast corner. We've got a scale factor here that's appropriate for this location. Now, by assigning the scale point at this corner, southeast corner, this corner will retain its original state plane coordinates. As you move away from this point, everything will be adjusted by this scale factor. So for a small job, a very small job, you can have your cake and eat it too, or in this case you can have a localization and still work in nearly state plane coordinates. Let's store those 2 points again. Store the south. We'll store the northeast corner. We'll inverse between them. And you'll notice that the ground distance now is displayed 5284.702, and the old grid distance is shown over here. The bearing is still exactly the same. Let's make a new project, and in this job we're going to set the southeast corner of the section to 10,000, 10,000, but we're going to align the basis of bearings for our new job to geodetic north. To do that, we can make a new job. We'll go to Equipment, Localization. On the GPS tab, let's bring our job up to ground. So I'll move us to the southeast corner. We'll read the GPS receiver to get a combined scale factor. Let's change our 1-point azimuth to be geodetic, and we'll add a control point. Control point, we'll just hand type it in, 10,000, 10,000. We'll set the elevation to 0. Now we're standing at the point that we want to use for 10,000, 10,000, so we'll just read the GPS receiver here. And then we'll set the vertical control so that zero elevation doesn't affect our calibration. Click on the green check mark, save our localization, and then let's go store these 2 points. Go to Survey, Store Points, and we'll store the first point. And let's move up to the north corner of the section, and we'll store the second point. And you'll notice if we inverse between these points, we get a ground distance that's correct, but our bearing is the offset of the section as it was laid out from true north. Now it's 11 minutes 5 seconds. It was 1 degree 1841 before. So now we have a local system at ground that's based 10,000, 10,000 at this southeast corner. What if I'd like this east line of the section to be my basis of bearings? Well, that's pretty straightforward. We can just back out, go to the localization, go to the points tab. Now we'll make sure we're standing at the northeast corner, and we'll add a second control point. Now we'd like the second control point's northing to be 10,052.80, and we'd like the easting to be 10,000. If the easting is 10,000, we'll read the GPS at that location. In this case, we're going to do a 2-point rotate only. So we're going to set our scale to 1. 2-point rotate only means that we're not going to honor the measured distance here. We're actually going to still use the combined scale factor that we set on the GPS tab. SurvCE will ask us if we want to reprocess the raw file. Notice it's got the inverse of our combined scale factor there. We'll back out here, and we can inverse again from point number 1 to point number 2, and you'll notice that the ground distance is the same, but now our bearing is true north. So we've aligned our localized grid to be the east line of the section, but we've honored the combined scale factor to calculate the distance between the 2 points. For our fourth example, let's import a complex lot boundary and then localize to the points as we find them in the field. That way we can use the 1 or 2 initial points that we know with an initial localization to find the points. Now I've got this lot described in Carlson Survey, and what I've done is I've taken the deed description, entered it into Carlson Survey. It's got 3 or 4 complex curves in it. Let's just take this and we'll do a W block and write just the inside of this drawing out. We'll use everything that we've selected, and we're going to choose to export a 2010 ASCII DXF. We'll save it to this file, and then I'll move that file over to my data collector. We're in our new job. Let's go to the map view. We'll click on File, DXF, Import DXF. We'll import the DXF that we just wrote out, and now we've got the polylines from that job that we did previously. Now in the past, we might have converted the polylines to points. That's under COGO, Create Points, and then polylines to points. In the later versions of SurvCE, that's not required because we can pick endpoints and midpoints of lines. So we'll leave map view here. Now the only 2 points that I know of that I can walk to in the field is this east corner and the north corner of the lot. There's T-posts here. The rest of these are out in the bush. It's pretty thick timber. So let's do an initial calibration on these 2 points, the east and the north, and then we'll align that to the drawing. So let's import the drawing exchange file that we just generated in Carlson Survey into our job. We can do that under Map View, File, DXF, Import DXF, browse for the file. Now we've got the polylines associated with this job. In the past, we might have converted the polylines to points. We can do that under COGO, Create Points, Polylines to Points. However, that step's no longer needed because we can snap our local coordinates from the endpoints and midpoints. So let's go to Equipment, Localization. I can occupy this east and north corner. I'm going to go to GPS and make sure that I've got a geoid loaded. Since I'm going to have multiple points in my calibration, grid to ground doesn't make sense. Let's go to Points, and let's stand on the east corner here. I'll add a point. Now it wants to know the local coordinate values. I can get those by picking the endpoint of those lines. So now they're entered. I'll click on the green check mark. It wants to know the GPS coordinates for the east point. I'm standing there, so I'll just read the GPS receiver. I'm going to click on off and turn off vertical control. And now I'm going to race up to the top of the hill, to the north corner here. Well, before we do that though, let's just verify that we're in the right place on the drawing. We can do that by going to Survey and then Store Points. And let's store a point here at the east corner. Now, if I didn't know where this top T-post was, I could use this single point localization to stake it. That'll get me pretty close. In this case, I'm going to pick the point from the map. I'll make sure that my endpoint button is selected. And now my receiver will navigate me up to the corner. Okay, so we're close. Let's stand on top of the point. So at this point I'm standing on top of, I found the rebar and cap. Let's store that point as point number 2, and we'll call it N. And then I'm going to immediately go back out and store this second point into my localization. I'll go to Points. I'm going to add a point. Okay, my pencil's still on the point, so I'll come back. That's the local point. And I will read the GPS receiver. I'm standing there. Now when I click the green check mark to accept this, it's going to ask me if I want to overwrite the localization file. Yes, I do. And then it'll ask me if I'd like to reprocess the raw file, and I would like to. And you'll see that my localization has adjusted the polylines to match what I've observed in the field. Let's go through the rest of these points now and store them. So I'm going to move to the northwest corner and I'll store it. I'll move to the southwest corner. I'll store that point. We'll move to the southeast corner. And then we'll move to this rebar and cap. Now remember that I'm actually occupying the found locations, the monument locations for these points. Now I'd like to do a least squares adjustment of my polygon to the actual found locations. We can do that quickly by going to Equipment, Localization, Points. You noticed I needed to turn off vertical on this second point. And we'll add the local coordinates for the northwest. Zoom out a bit here. Okay. And then we've already occupied that point, so we'll just read it from the raw file. Turn off vertical control on that point. We'll add the southwest corner. Zoom to extents here. Read that value from the raw file. Turn off vertical control. I'll add the southeast corner. Pick the southeast corner from the raw file. Turn off vertical. Need to pick that point from the polyline. Let's see, that's going to be R. Got it. Again, turn off vertical control. And we'll add the final point. And turn off vertical control on that. Make sure I've got vertical control turned off on all of the points. You notice my residuals are pretty reasonable. They're all less than a couple of tenths, which, considering where this job is amazing. So our average horizontal residual is a tenth. We'll save the localization, and we'll reprocess the raw file. So at this point, our local polylines from our design are overlaid and adjusted to the found points that we found in the field. That's all there is to a multi-point localization.